now. All right, I'm glad you guys are here. So let's see what we got. Graph quadratic equations and determine solutions. So this is what we're going to be doing today. And like I said, we're going to save the factoring for the next lesson, I think. It's going to be hopefully not a very long lesson. We already know a lot of the basics stuff like how to graph. So what we're looking for, so the solutions, so solutions are kind of like the answers in a way, but they're a specific kind of answer because we're looking for something that intersects the x-axis, right? So we know that parabolas have two parts, usually one that goes up and then the other that goes down, or sometimes they can start from the top and then go back up. But they usually have two directions, and since they have two directions, there's a couple of things they can do. But also zeros are referred to as roots as well. So zeros and roots would both be the solutions. We can also call them the x-intercepts. I think there's like one more word. I forget what it was, but I know there's another word that they have for it. And for some reason, there's a lot of words for it when there really doesn't need to be that many words. But anyway, those are the three things. So if I say solutions, zeros, or roots, or x-intercepts, then it means all the same thing. It's all the same thing. So what are the solutions? Well, here we have two of them. So two solutions, because we have one crossing here and one crossing here. So there's two places that it crosses the x-axis, the intercept. So intercept just means like crossing, but it doesn't really have to cross either, because here we're having the parabola contact. So it's just like touching and then it kind of goes back the other way. There's only one, so we only have one intercept on the x-axis here. So again, only 1, 0, 1 solution, 1 root. And then there's also a third option where it does not either contact or cross the x-axis. And in that case, there would be no real solutions. And we say no real solutions because there is technically kind of a solution. They're called complex numbers, but I think that's going to be a whole lesson all on its own some other day. But we just say no real solutions. So yeah, it's not just no solutions, what I'm trying to tell you. So you got to kind of put no real solutions. All right, so let's go ahead and get into what we're going to do here. So we're going to use that same formula, our axis of symmetry formula that we've used before. And that's going to kind of be our starting point here. So let's go ahead and get our axis of symmetry. That's the first thing we're going to look for. So remember, we get negative b over 2a. So negative b, so we take our, remember, we got to check it to make sure that it is in standard form. So x squared, x to the 1 power, x to the 0 power. So it's got to be in order. Otherwise, if it's not in order, sometimes it will be, you know, sometimes they will make them out of order and then you have to put them in order first. So in most cases, they will just be in order, so you don't have to worry too much about it. But sometimes it will trick you, or sometimes they'll be missing values. So like they'll be missing one of these or one of those. All right, so first things first, let's go ahead and find out where the middle is going to be. So the axis of symmetry. So negative b, so we take the opposite of our b value, which is 2, and then divide that by 2 over a, which in this case, my a value is just 1. So negative 2 over 2, so this is going to be, well, it's going to be that, and we have to simplify it. So this means that our x-axis, so that means we're going to have the line of x equals negative 1. And in this case, I'm going to go ahead and put the axis of symmetry here. I don't know if it says it's necessary. I don't think it said. Let me look at the packet, and it says that it is not necessary. Okay, so yeah, but it's useful. It is useful to have. So from here, we're going to have to make a table, and that's probably one of the best ways to do this is to use a table. So to get the table, I'm going to start off with my number in the middle, so negative 1, and then I'm going to number down negative 2, negative 3, and then I'm going to number up. So I can make a little diagram. with x's and y's, or f of x's. And we're going to plug each of these numbers in and see what we get. Now, I think what I'm going to do is, well, what I want to do is I want to start with the middle number and see how far it goes. Okay, so we don't need to fill out the entire table, because as soon as we have our zeros, then we should know what the solutions are, and we don't really need to go any further than that. So here we have y equals, we're trying to find out where y equals 0. So if anything in this column comes out to be 0, then that's what we're looking for. All right, so let's go ahead and plug in -1 and see how far away we are. And let me go ahead and move this out of the way for now. Oops, gonna move that whole thing. All right, so let's go ahead and plug in -1. So into our original equation, we have x squared plus 2x minus 3. And then again, we're going to plug in -1 will be our first one. So -1 squared, so that's -1 times -1. And then 2 times -1 would be -2 minus 3. And from here, it looks like we just have to do some subtraction. So, well, I can put the two negatives together. So I get 1 minus 5, because this is -2, -3. And that's going to make it -5. So 1 minus 5 would be -4. So I'm going to start plotting this now, because this table is only here to help us graph. All right, it's not like the last assignments where the table was necessary and part of your answer. All right, so I can kind of tell where this is going, and if you're really smart, you don't have to do all of them, because you're going to be able to kind of figure out, you know, looking at what we call the key features or the rule of odds. Hopefully you remember enough of those where you can kind of guess where the next one's going to be. So looking here, you probably could make a pretty good guess at where it's going to cross the line, and then try that number. If not, then you're just going to have to plug each one in every time and see how it goes. All right, so the next one's going to be -2. All right, so let's see, -2 squared, so that's -2 times -2 is 4. 2 times -2, so it's a negative times a positive, so it's going to be a negative. 2 times 2 is 4, and then 3. So 4 minus 4 would be 0 minus 3, and now we know that this would be -3. So -2, -3 would be right here. And again, if you know a little bit about parabolas, you know, this is going to be a little bit easier, because again, you can kind of guess where it's going to end up at. So I can pretty much tell this one is going to be one of the zeros. But let's go ahead and keep going. All right, now I'm going to go ahead and plug in -3. So -3 squared would be 9, because again, -3 times -3 would be 9. 2 times -3, so it is going to become a negative. 2 times 3 is 6. And bring down the -3. So no, actually, you know what? I could put these two together right here. So -6, -3. Put them together, you get -9. 9 minus 9 is 0. And again, this is what we're looking for. We're looking for where we can get y values that equal to 0. That's why they're called zeros. That's why they're called zeros, because on here, this is where y equals 0. So we have one of our solutions now. And we can go ahead and keep plugging in for the rest of them. And actually, in this case here, I don't really need to try it, because all I have to do is just verify it. So let's see, I have 2 spaces from the axis of symmetry, so 2 units. Go 2 units in the other direction. And here we get x equals 1, which is going to be right there. So let's go ahead and try 1 right here. So again, you don't need to try all of them. If you're really, you know, if you remember a lot of the basics, then you can kind of focus your guesses a lot better. 1 square, let's see, 2 times 1 will be 2 minus 3. And if I were to put 1 and 2 together, so they're both positive, +1, +2, it's going to be +3, which I get 3 minus 3, which comes out to be 0. And again, I didn't really need to do 0 here. which if I did, it would just be -3. And again, I don't need to fill out all of these things. I just need to look for the outcomes, the outputs of the function that are 0. And in this case, we're pretty much done, but I can still see that we have our parabola like that. And it says here to graph it anyway. So we are going to continue graphing it. And there we go. Now we have our parabola ready to go. And we can see again our zeros. So just to show you, we don't need to circle them every time. But if I circle them, you can see where they are, what number they are. And in this case, let's name the ordered pair in which they belong to. Which, let's see. Oh, the ordered pairs are in this column right here. So -3, 0. And then the other one would be, should I put an and in there, or I don't know. And then the next one would be 1, 0, or yeah, I said 1, 0. I must put 0, 1. But anyway, here is the solution. Oops, wrong color. Those ordered pairs are, again, where we have the line crossing the x-axis. All right, so there we go. Again, not too much. You don't need to do everything, but okay, let's see. We found the solutions and we graphed it, so I think we're good. That's it for this one. Let's move on to the next one. All right, same thing here. So before we even start, we can gather a few things that we kind of are going to be able to tell what's going to happen with this graph before we even start. So there's a negative a value, and that negative a value usually means that it's going to be facing down. So our parabola is going to be opening downwards. And it also has a value of 1 and -1, so you can use the rule of odds to do this. Maybe I'll kind of point that out now. If you're not sure, you're just going to have to kind of do all of them. You're just going to do all of them filled out every step. So let's go ahead and move this, use our, axis of symmetry formula. So -b, which in this case is already -10. So I end up with 2 negatives. 2 times a, so a is -1. And here I get 10 over -2. There you go. So my axis of symmetry is going to be -5. So x equals -5. So this is that's going to be the line for my axis of symmetry. And that would be right here. There we go. So now again, I know that it's going to be somewhere here and it's going to be opening downwards or something. So that was just a guess. All right, so we do know a couple of things. We know our axis of symmetry. So if I were to make a table, let's put -5 in the middle, and we can always put more numbers in there later. So let's go ahead and number down, and then number up. So I'm just going to go with 2 in each direction, and if we need more, we're going to have to fill in more. All right, so let's start off with our axis of symmetry because, well, something's going to happen there. And it pretty much has to include it. And once we also plug in the axis of symmetry, we will also get the vertex. And we can kind of, again, guess how much distance we would need to go in both directions. All right, so I'm going to go ahead and plug this in. Oops, almost forgot the square. -5 is our first one, so first one's going to be -5. And that'll help us, again, pick our guesses a little bit better. So now this negative here is going to be squared out because -5 times -5 will be +25, but this negative is just going to jump on the number in the next step. So it stays negative. Over here, we have -10 times -5, which is going to be positive, so +50. And the -25 is going to come straight down here, so okay. -25, -25 put those together, you would have negative 50. 50 minus 50 would be 0. Or however I add this, I'm always going to end up being, it's going to end up being the same thing. 50 minus 25 is 25. 25 minus 25 is 0. So there we go. We have it. So we know the vertex is going to be right here. Now, if you were looking at the packet where we have the 1 solution, 2 solution, no solution, or no real solutions, you'd probably already kind of have an idea of what's going to happen. But let's keep going anyway. So again, we know we can use the rule of odds, but let's do 1 in both directions. So let's go with negative 6. I'm going to go with negative 4 just because it's a slightly smaller number. And we already know that it's going whatever 4 or negative 4 is, it's going to be the same for negative 6. So negative 2, well, let's see, negative 4 times negative 4 would be 16. But again, it's going to be made negative because of there. Plus 40 minus 25. All right, let's see what we get. And if it helps, we could use a calculator. So I'm going to go ahead and put 16 plus 25 together, and we get 41. So 40 minus 41, because I put my 2 negative numbers together. And this is going to be, oops, almost hit my calculator. It's going to be negative 1, negative 1. So if I go back 6, down 1, and then I'm out to do the same thing at 4, back 4, down 1. And again, this follows our rule of odds. So it's going to go down 1, and following the rule of odds, remember that it goes by odd numbers. So it'll go down 1, then down 3, then down 5. And sometimes you'll have enough space to go down 7. So 1, 3. And if I were going to have another point, it would be like right there. But this should be enough. And again, the table isn't really necessary to fill out if you kind of already know what the parabola is going to look like. Well, it still has to follow the rules of the parabola too. So in this case here, we know it's going to look like that. Okay, I moved the graph a little, I moved the graph a tad. So let me go ahead and fix that up. So there we go. We only have 1 solution. So it barely contacts, right? So as we come from left to right, the line goes up, the function goes up, makes contact, and then just goes back down. So we only have 1 space where we have an x-intercept. So in this case, we only have 1 solution, and let's go ahead and name that solution, which is going to be negative 5, 0. Just like that. So just 1 solution. So again, here we have to put our solution there. On the packet, it does say, like on the far left side, there's a line after 1, 2, and 3. That's actually where you're going to put the solutions that you get. And on the back side, it's gonna be the same thing as well. So on the back side, it's going to have lines for 4, 5, 6, and 7. So you're going to put those down there when you get there. Anyway, so we're done with this one. So again, it's not going to take as long as you use a lot of the things that we've already learned. So this is where it pays to know a lot of these little tricks that we've picked up along the way. All right, so let's go ahead and move on to this one. So I'm going to start with again, finding the axis of symmetry. So first thing I'm going to do is put the negative b over 2a. And let's drop our b value in here and our a value in here. So this is going to be negative, or opposite of negative 6 is the way you would read that. So the opposite of a negative 6 is positive 6. 2 times 1 would be 2. 6 divided by 2 is 3. So x equals 3 is our axis of symmetry. So we know that whatever happens on this side of the graph is going to happen on the other side in the exact same way. So let's go ahead and plug in our first number. Or let's make a table, and I'm trying to think of how would be the best way to do this table. So we could put 3, and I'm going to just start like this. I'm going to go with 3, and then one number up, one number down. Wait, no, that's not right. Number up would be 4. And we may or may not need more than this. So let's start off with our middle number again. Just once we see the vertex, we can kind of gauge where the next numbers are going to be. So we don't need a big table. And again, you can be a little bit smart and guess the numbers and be done a little bit quicker so you don't have to do so much work. So let's see, x squared minus 6x plus 8. So I'm going to put in 3. That's our first number. So put 3 in there. 3 squared is 9. And then here I have 6 times 3, which is 18. But I have a negative times a positive, so that's going to be negative 18. And then plus 8 is going to come down here. I'm going to put my two positive numbers together. So I have 9 and 8. If I put 9 and 8 together, that will be 17. So I end up with 17 minus 18, because the 18 is still going to be there. Now 17 minus 18 is going to be negative 1. So just looking at our vertex, over 3, down 1. And again, looking at, well, we should have started this before we started graphing it, but we also see that it's a positive 1 value. So that means we can use the rule of odds, and it opens upwards. Because, you know, if it opened downwards, just as an example, then there would be no solution. But in this case, it opens upwards, so there is a solution. Or in this case, there's 2 of them, because it would have to cross somewhere above our vertex. And in this case here, we kind of guessed right, because we only needed 2 spots. Once we know where the graph is, and again, you can also just do the whole thing too if you're not sure. So let's go ahead and put 2 in our up here. So let's put 2 in as our x value. So 2 here, 2 here. So 2 squared is 4. And let's see, negative 6 times 2 would be negative 12 plus 8. All right, and put my 2 positive numbers together. I get 12 minus 12, because 8 plus 4 is 12. And then 12 minus 12 is, well, 0. And it's got to be this way too, because again, if we follow our rule of odds, if I were to go 1 space upwards, it would look something like that. Up 1 over 1. And then as I move to the next one, it would be 3. So again, it goes 1, 3, 5, 7. So 1. And then from here, go up 3 over 1, and then up 5 over 1. Up 3 back 1, up 5 back 1. And we were able to get our parabola set up, no problems. And sometimes, like in this case here, it doesn't really want to go through the line, so I'd have to kind of make it high up like this. Otherwise, it's not going to go through all the points. So maybe for this one, it'd probably be better for me to just draw the line, because this graph is actually kind of a bigger graph as well. And don't forget, when you're drawing the parabola, there's going to be a slight curve to it. And the curve gets less and less gradual the further you go out. So again, no straight lines. I know it's like a coloring book connect the dots thing. Sometimes students will kind of go to that. But it's not that bad. So again, there you go. All right, now we just got to name our solutions. So what solutions do we have? So I have this. Well, actually, I can also check the table, but we can also look at the graph. Our solutions in this case would be, let's see, 2, 0. And then we have the other one at 4, 0. So, oops, got to open the parenthesis. So 4, 0. There we go. So those are our 2 solutions. So again, 2, 0, and then 4, 0. And there you go. We're done with this one. Not so bad, like I said. It's not going to take as long as just full on graphing some of these, because sometimes graphing them, you know, if you have to fill out the whole table, it can take a while. But again, if you really, you know, think ahead, you can kind of tell what's going to happen here. All right, let's go ahead and move on to another one. Okay, so let's see. First thing we got to do is, well, okay, so first thing we should do is check it to make sure that we kind of know where the direction it's opening. So our A value is -1. So this means that we can determine that it's opening downwards. And it's also going to be a regular parabola as well, so it will follow the rule of odds. So we can, again, kind of predict that. So let's go ahead and, well, let's try that. Let's try to predict without putting a full table. And again, if you're not sure, just make a full table so you don't have to listen to everything I say. Okay, you can make a full table, but what I'm trying to do is trying to tell us that we can also pick spots that we're sure are going to happen. So again, like if you're digging for treasure, you don't just dig everywhere, right? You kind of follow clues. You look for anything that would help you find where to dig, because you don't want to be spending a lot of time digging and not finding anything, right? So any task you do, there's always a way to kind of make it a little bit shorter, you know, focus your effort so you're not working so much, doing all that extra work that isn't really needed. All right, so here, I'm going to use a calculator for this one here. So 11 divided by 2 is going to be 5.5. So this means that we have a line like this. 1, 2, 3, 4, 5. Yeah, it's going to be a little bit more than -5. So between -5 and -6. Now we're going to put this in our middle. Now this might make it a little bit tougher. So let's go ahead and plug in to our function here. So again, we need to at least know where the vertex is. Once we know where the vertex is, hopefully we can kind of hopefully try to guess what number it would be, and we can kind of adjust our guess up and down if we need to. All right, so next number is -11, and then -5.5 x minus 28. So now I don't know what 5.5 squared is, and in this case I have a cheat calculator. And if you don't have a square button, just push 5.5 times 5.5. And in this case, it looks like we get 30.25. And again, this negative right here inside the parentheses is gone, but the outside one is still going to be there. And then here I have a negative times a negative, which is going to turn it into a positive. So now I'm going to go with 11 times 5.5, and that's going to be 60.5. All right, now I got a lot of decimals, so I'm going to go ahead and minus 28 and minus 30.25. And that should give me 2.25. So 2.25. And is it negative or is it, yeah, it's positive. So back 5.5 up 2.25. So like that. So it's a little bit over. Now, if I try to guess, so go down 1, which would be about right here, over 1. And then from here, I'd have to go down 1, 2, 3 over 1. And just projecting it, just imagining where it's going to cross, it'll probably cross very close to here. Now, if it does that, let's go back to the axis of symmetry from here. So 1.5. So 1.5 would be about right here. Now, what we need to do with our equation is to verify it. We just want to check it to make sure it'll actually work, because it might be a little bit off. Instead of saying like -7, it might be something like -7.25 or something like that. So it might just be slightly off. So let's just try it anyway. Let's try 7. That'll be our first one. So let's try -7. Actually, -7 would be above here if we're counting up. And the next one would be -4. -7 here, -7 here. All right, so -7 squared, it's going to be 49. But again, this negative is just going to jump right on there. Negative times negative is positive. 11 times 7 is 77. And it looks like I have 2 negative numbers. So that's going to be 49 and 28. And that is going to be 77 if I were to put them up together. So 77 minus 77, that's going to be a 0. And let's also verify -4 as well. So I'm going to go ahead and erase this. And if you're doing this, go ahead and just use a separate sheet of paper. You don't need to erase it because you're going to use up all your eraser if you do that. And your paper is going to be very smudged. So I'm just doing it this way because I don't have a whole lot of space to write all this stuff out. So let's see, negative times negative would be positive, and I get 44 here. Now I have 2 negative numbers, -16 and -28. So I'm going to add those two together, and I do get -44. So 44 minus 44, that's also going to be a 0. So in this case, we managed to guess correctly. And then from here, go down. Okay, so that problem may be a little bit off, but that's okay though. In this case here, we're not trying to get an exact thing. We're really just looking for these zeros. So we have them now. So that would be -7, oops, -7, comma 0. And then the other one is -4, 0. And again, don't forget on your packet, there's a column on the far left. So go all the way to the left, and you will have a line with the number next to it, and that's where the solution goes. And there you go. It looks like we're done with another one. Let's move on. And I think we only have not very many more to go. Looks like we only have 3 more to go. Okay, and I think we're going a little bit further because I'm kind of cutting out a little bit of the fluff, right? Because otherwise we'd have to fill out this entire table with 3 numbers up, 3 numbers down, just to make sure that we have it. But we're skipping a couple of numbers, and we're just leaving out some numbers because we kind of already know, knowing a few things like the rule of odds, we don't need to check all of them. And that's kind of what I'm hoping that you're going to do as well. Anyway, let's go ahead and do this one. So we have something a little different with this line. We are missing one of the values. In this case, we are missing the B value, right? Because I know some students will be like, well, this is the second number, so I must put it in our axis of symmetry formula right here. No. So remember, whenever you're missing one of the numbers, you got to check it which one it is. So like if this was 9x, then it would be a B value. But in this case, there is no x value, so that means it is a c value. So we only have A and C. So for the B value, in this case, we have 0. We have nothing. So 0 cannot be negative, so that negative is just going to go away. 2 over 1 is going to be 2, or sorry, 2 times 1. 0 divided by 2, well, it doesn't really matter. 0 divided by anything is always going to be 0, right? Because if you have 0 Skittles and 2 people, nobody has Skittles. If you have 0 Skittles and 10 people, still nobody has Skittles. Anyway, so now we know that this axis of symmetry is going to be right here along the y-axis. Okay, now we also need to find out where the we've got to find out where the vertex is. Sorry, I almost forgot the word vertex. So let's go ahead and plug it in. So 0 squared minus 9. So 0 squared is going to be 9. Oh, 0. 0 minus 9 is negative 9. So actually, in this case, our vertex is going to be way down here. And normally I wouldn't mark something if it's outside the graph, but in this case I am going to. Just because we are going to need to use it. Now, looking at our a value, we can see that this is an a value of 1, positive 1. So the graph is going to open upwards. And since it has a coefficient of 1, or sometimes negative 1, it's still going to follow the rule of odds. So it means 1, then from there up 3, then from there up 5, and then from there up 7. So actually, without doing any of the tables, we were able to pretty much finish this one. And in fact, you know what? Let's just go ahead and skip the table on this one, because this one's a very simple one. It doesn't have any of this extra stuff. So let's go ahead and follow that rule of odds again. So up 1, and then 3, and we're still moving 1, so we're still moving 1 in the other direction, and then 5, and then 7. There you go. So now we have a very, actually this is probably one of the largest parabolas that we've had in a long time. I'm not sure if this tool is going to work for this, because now you can see that there's a few of them that are just being left out. The only way I can really make it work is if I stretch it all the way up here. But then that's kind of distracting. So I'm going to just try my best to draw it again. Make sure to get a little curve in there, because it's not a straight line. All right, it'll do for now. So there you go. Like I said, that's one of the biggest graphs I've seen. And now from here, since we didn't make a table, we can look at the graph and see where the solutions are. So it looks like I have negative 3, 0. So I'm going to put that on there. So negative 3, 0. Close that parenthesis. And the other one looks like it's going to be at positive 3, 0. So 3, 0. There we go. And again, it didn't say nothing about fill out the table. So that's, since the directions never said, you know, you have to fill out the table, because I know in one of those other assignments, it did say to do the table, but in this case, it doesn't. It just says, find the solution and then graph it. So as long as you have your graph and your solution, you should be fine. Okay, so this one was a really quick one. All right, let's go ahead and move on to the next one. All right, now this one is also missing one of the terms, right? Because we have the square, we have the x to the 1 power, which again is just plain old x. What we're missing in this case is our c value, which is in this case z. So anytime we need to calculate a c value, we use a 0 in its place, which in this case here, let's go ahead and plug it into our axis of symmetry. So I'm probably going to need this. I'm going to move it over here. All right, so let's go ahead and find the axis of symmetry. So negative b, which in this case is going to be 6, and then 2 times 2, because 2a, which my a value is 2. And since my a value is 2, I can't really use the rule of odds with this one. There's a slight change on the rule of odds, but that, you know, I know sometimes it feels like there's just a lot of rules to remember. And when that happens, people don't really want to take the time and remember all those rules every time. So in this case here, I have 6 divided by 4. So I'm going to use my calculator, 6 divided by 4. And we're going to get, in this case, negative 1.5. So put our axis of symmetry right there at negative 1.5. There we go. Now let's go ahead and find our vertex here. So vertex in this case is going to be plugging this back in. So 2 times x, which in this case, let's start off with, again, 1.5 squared plus 6x, which is, again, 1.5 negative. All right, so again, we could use a fraction, but I'm going to just stick with decimals in this case because I know there's a lot of stuff with decimals. Let's see, 1.5 times 1.5, when we get 2.25 plus, and then here I have 6 times 1.5, and that would be -9 actually, so -9. Oh yeah, that makes sense. That makes sense. Because if you times something by 1, you're going to get 6. But if you were but if you're going to take 6 and times it by 2, you would get 12. So what number is exactly between 6 and 12? Well, it's 9. All right, so let's go ahead and go with 2 times 2.25. And I think I already know this one. It's going to be like 4.5. So 2 times 2.25, and that's going to be 4.5. Yep. 4.5 minus 9. And since 4.5 is already half of 9, I know that, okay, so let's go ahead and put -1.5. And our outcome would be -4.5. So this is our vertex. So back 1.5, down 4.5. So it's 3, 4.5 would be like right there. Now in this case, we cannot use the rule of odds because we have a 2 here. So that's going to throw things off. So in this case here, we might just need to fill out a whole table. So I'm going to go ahead and count upwards. So I'm going to go ahead and do the next number, which is going to be -1, then 0, and then maybe +1. I don't know if this is going to be enough. But remember, since it's a 2, that means our graph is going to be stretched. So it's going to be narrower. The parabola is going to be a little bit less wide. So it'll probably reach one of these numbers a little bit sooner. Just a guess. Okay, that was just a guess. So it's going to be a little bit narrower than a normal parabola. So let's go ahead and start plugging things in. So let's go ahead and do -1. So I'm going to plug in -1 into our formula here. -1, -1. So here I have 1, or -1 squared, which is going to be 1, times 2, plus, and then here, oh, actually that'd be a negative because that would be, that -1 would transform the 6 into a -6. Then I have 2 minus 6, which is going to be -4. So -1, -4 is going to be like right there. And let's try 0 next. So I'm going to plug in 0 and see what differences we get. So 0 squared is going to be 0. 0 times 6 is going to be 0. So this is going to be 0 plus 0, which is going to be 0. Now we have one of our, we have one now. We have one of the zeros, which means the other 0 is going to be right there. Okay, because again, looking at the axis of symmetry, it's the same distance from both from both zeros. Both zeros are going to be 1.5 units away from the axis of symmetry. But again, I'm going to verify this too. So I'm going to plug in -3. And let's see if it comes out to be 0. And sometimes that's a good thing to do because if you made a mistake, because especially in this case here, we're dealing with some decimals, which we don't normally deal with. And if we do make a mistake, it's good to kind of see it, have it, you know, pointed out to us by checking it again. And we're not really checking it again, really. We're just doing a different problem. Anyway, -3 squared is 9. 2 times 9 is, well, okay, well, let's wait till we get there. So 6 times -3 is 18, but it's going to be negative because of this 3 here. And here I get 2 times 9, which is 18. Bring down this -18, so we get 18 minus 18, which is going to be 0. And again, that's the main thing we were doing, is just trying to verify, right, where the zeros are. And we're doing our best to guess. Now, in this case here, we might have had to try out more, which is kind of why I left some space up here and down here. But again, once you find your zeros, you don't need to go any further than that. So sometimes you do have to make a chart, table. Anyway, let's go ahead and finish up our parabola. So I'm going to draw this out. And again, it should be a little bit narrower than a typical parabola that you might see, because of that a value. If it's high, it's going to be, if it's higher than 1, if it's like, whether, even if it's negative, like if it's, well, anyway, I guess I should just leave it like that. That way I don't want to confuse anybody anymore with any other information. So there we go. That is the graphing parabola here. We got our solutions. So that is it for this one here. Let's go ahead and move on to, I guess, the final one, because I can see there's only one left, and we'll save the next one for another lesson. What is today? Tuesday. I wonder if this week has an early dismissal day on Wednesday. I'd have to check the schedule. Anyway, let's go ahead and find our axis of symmetry here. So negative b, so here we have positive 8, so we're going to have to make that into a negative 8. 2a, which in this case my a value is negative 1, which means I can use the rule of odds, but this graph is also going to open downward, so we're going to have something that kind of looks like that. Negative 8 over negative 2, and since they're both negative, negative divided by negative is going to be positive. 8 divided by 2 is going to be 4. So our axis of symmetry is going to be somewhere at 4. Let's use the right kind of line. So I'm going to mark out our line at 4. All right, now let's find our vertex. So we know that this should be the middle of the table. And again, we don't need to fill out the whole table all that much, because once we know what one of them is, well, once we know what the vertex is, it'll help us kind of guess where the other one is. So negative x, which in this case we're going to use 4 first, minus plus 8x, which we're using 4, minus 17. All right, so negative 4 plus, here I get 32 minus, I said 32, not 30, minus 17. And let's see what we got. 32, because I'm going to keep the positive, but I'm going to put my two negative numbers together. And my two negative numbers would be negative 21. I think I missed something here. Oh, I know what I missed. I forgot to put the little square there. That's like the third time I almost forgot that already. Oops, my bad. Because I was thinking that's kind of a high number. It should be somewhere between like 8 and negative 8, because you know we have to graph it. It's got to be graphed somewhere. All right, so again, this should be 16, because 4 squared is 16. I just forgot that little square there. All right, now this is probably going to be a lot better. So move the 32, and I'm going to put my two negatives together. So since they're both negative, I'm just going to treat it like I'm adding them. So in this case, it's going to be negative 33. 32 minus 33 would be negative 1. So over 4 down 1. So that's our vertex. Now from here, well, we're going to run into some issues because our parabola is opening downward, remember? So if it's opening downwards, it's going to look something like that. And we're probably not going to get any solutions or any real solutions. Now, just to make sure, let's go ahead and plug in a few other numbers. We could plug in a few more. We could plug in 5 and 6, and then plug in 3 and 2, just to see again. Because if we did make a mistake here, like we already almost did, we got to make sure that all these lines are going to also match. So let's go ahead and do that same thing here. And use, I'm going to start with 3, and you don't have to go in any order. I'm just going to pick whatever order. So 3 squared is 9, but that negative on the outside is going to affect it. 8 times 3 is going to be 24. And then let's see, I'm put my two negative numbers together, 9 and 17. And that's going to be 26, so negative 26. And that means this is going to be negative 2. And it's also safe to assume this one would also be a negative 2. So over 3 down 2. And then down here we'd have over 5 down 2. And we can kind of already see that our parabola is opening downwards. And you know, well, if the line was like somewhere else, you know, then you made it, we would have made it an error in the vertex. But in this case here, it looks like there is no error, and this is just the way the graph is supposed to look. Let's go ahead and put 2 in there. 2 squared is 4, but we're going to have to make it negative, plus 16 minus 17. Normally I put the negatives together, but since 16 and 17 are so close together, I'm going to go ahead and I'm going to make this 16 minus 17. And that's one good thing, is you can always do this in whatever order you want, because it is commutative, meaning that the order doesn't matter. 16 minus 17 would be negative 1, and that would make this negative 5. So over 2 down 5. And this does follow the rule of odds. 1, then 3, and then the next one would be 5. And then this is a standard shaped parabola, so it's not narrow, it's not widened, or as we call it, compressed. And we have no area, again, with intercepts. So since there are no intercepts, there's going to be no real solutions. Well, I'm going to just move that over to the next line just so that way I can fit it in there. Just to make it look a little bit more professional. I'm going to go ahead and capitalize the letters. I don't know if that's really necessary. But in this case, we have no real solutions, because it never crosses the x-axis. And there were a few ways that we can check it, because sometimes some people will do things like, I don't know, forget a negative, and that's going to flip the graph. So it's worth it to check it again, make sure you didn't miss anything, or I don't know, like in some cases we put up a few checks. So like putting a few extra numbers in there kind of told us, okay, so that's what's going to be put there. All right, so that takes care of that first part of the packet. There's also the part that says factoring refresher. So factoring refresher, we don't normally do Zooms on Wednesdays. So we'll do that one on Thursday. And then for the homework, I think that's going to count for more. Actually, it's going to be a bit of a weird thing, but I know it's kind of a little bit off because I missed the day. I was out on Monday, so that kind of, well, throws things off a little bit. And we're back on the regular schedule too. So after this week, we're going to continue the schedule we had before spring break. So that's going to be pretty much Zooms only for math classes and other classes that are paired with math. You're going to have your Zoom on Mondays and Thursdays, and we're going to have the occasional one on Tuesday. Like if I miss Monday, or you know, something happens like there's a holiday on a Monday or something, then we're going to make it Tuesday and Thursday. But otherwise, most weeks are going to be Monday and Thursday. Then we're going to have most Wednesdays are going to be half a day, so there's not going to be any Zoom. And then Fridays are going to be our tutoring days as well. So, and Tuesday and Friday are the tutoring days. So it's going to go back again. This is just this exact same schedule that we had before break. Although I think I'm going to keep a few changes on the times, just in case we open the school back up again. Because having to change the times was a pretty big hassle. Changing it onto schedules with students, and then now we're taking it back off. And I don't know if we're planning on it again, but I think a lot of the people at our school really, really want it open again. Not the teachers, but, well, there are some people that want the school open, and that, you know, they're going to try to do what they can to open it. And that's not a good thing, not a bad thing. You know, it's good and bad to both sides, because it's good to have students in here that you can work with, but then it's also kind of bad because, you know, what's going on, and you don't want to cause any spreading or anything like that. So it's not like, it's not really, again, right or wrong, but it's just how things go. And, you know, we're probably going to, you know, not my guess, but just to be ready for it. You know, whatever happens, I'm going to keep the times the same. So I sent out an email with the times and all that stuff on there. So look out for the times, look out for the days, and I resent the Zoom links too. So I think I got a new student as well. So hello, new student, if you're watching this. Anyway, so that's going to be it for today. I will see you again. We'll have our next lesson on Thursday. And you can, I think I'm going to start opening the Zooms up on Wednesdays again, just for attendance and for questions and tutoring. But again, I'm going to try to save the real tutorings for Fridays. Anyway, that's it. Bye-bye.
Okay, bye.
Thank you.